When performing a service changeout involving an old Zinsco panel and a new panel, several code considerations come into play. The primary concern revolves around the proper termination of service entrance conductors. A potential code violation arises if the service entrance conductors are directly terminated into the top lugs of the main breaker in the new panel. This practice is generally prohibited for any breaker in any panel. However, there's an alternative method that complies with the code. Instead of terminating the service conductors directly into the main breaker, a separate lug kit can be utilized. This involves connecting the service conductors to the lug kit and then using a short piece of new service entrance conductor to run from the lug kit to the breaker. This short conductor does not need to be derated because it only carries the load to the breaker, and the breaker, in turn, carries the load to the bus. When using clamps for splicing conductors, it's crucial to choose the appropriate type. The orange-winged variety of 2-screw clamps are recommended because they consistently tighten down to the same torque, ensuring a secure and reliable connection. The configuration of feeding the new panel through a nipple on the old panel might initially raise concerns about it being mistaken for sub-panel feed. However, based on the description, it is acceptable. The National Electrical Code, or NEC, is the primary standard for electrical installations. Several articles within the NEC address service equipment panel board installations and conductor terminations. It's important to consult the latest edition of the NEC for specific requirements. Article 230 covers service entrances, including service conductors, disconnecting means, and overcurrent protection. Article 408 addresses panel boards and their installation requirements, including conductor termination and bonding. Article 310.15 and related tables cover conductor ampacity and derating factors. Understanding conductor ampacity is crucial for ensuring the safety and reliability of electrical systems. Ampacity refers to the current carrying capacity of a conductor, expressed in amps. The NEC provides tables that list the ampacity of various conductors based on their size, insulation type, and installation conditions. When conductors are installed in raceways or cables, their ampacity may need to be derated to account for heat buildup. Derating factors are applied based on the number of current carrying conductors in a raceway or cable, as well as the ambient temperature. Proper conductor termination is essential for preventing overheating and ensuring reliable electrical connections. Conductors must be properly sized for the load they will carry, and they must be terminated in accordance with the manufacturer's instructions. Terminals and connectors must be listed and labeled for the specific conductor type and size being used. Over-tightening or under-tightening terminals can lead to loose connections and overheating. Bonding is another critical aspect of electrical safety. Bonding refers to the intentional connection of metallic parts of an electrical system to create a low impedance path for fault current. This helps to ensure that overcurrent protective devices, such as circuit breakers or fuses, will quickly trip in the event of a ground fault, minimizing the risk of electric shock and fire. The main panel must be properly bonded to the grounding electrode system. This typically involves connecting the panel to a ground rod, metal water pipe, or other approved grounding electrode. Equipment grounding conductors must be installed with all branch circuits and feeders to provide a path for fault current back to the source. Splicing conductors within the old Zinsco panel and extending them to the new panel is acceptable, provided that all splices are made in accordance with the NEC. Splices must be contained within an approved enclosure, such as the old Zinsco panel. The splices must be made using listed and labeled connectors that are suitable for the conductor type and size being used. The connectors must be properly tightened to ensure a secure and reliable connection. Snap-in connectors and 2-screw clamps can be used for terminating conductors in the panels, provided that they are listed and labeled for the application. The orange-winged variety of 2-screw clamps is preferred because they consistently tighten down to the same torque. When replacing an old Zinsco panel, it's important to address any potential safety hazards. Zinsco panels are known to have certain design flaws that can lead to breaker failures and overheating. It's recommended to replace the entire Zinsco panel with a new panel that meets current safety standards. Before beginning any electrical work, it's essential to disconnect the power supply. This can be done by turning off the main breaker in the service panel. It's also a good idea to test the conductors with a voltage tester to ensure that they are de-energized. Always wear appropriate personal protective equipment, such as safety glasses and gloves, when working with electricity. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in accordance with the NEC. Service entrance conductors refer to the wires that bring electricity from the utility company's service drop or lateral to the building's service equipment. These conductors are typically larger than branch circuit conductors because they carry the entire load of the building. Service entrance conductors must be properly sized for the load they will carry, and they must be protected from physical damage. The NEC specifies the minimum size of service entrance conductors based on the calculated load of the building. The load calculation takes into account the square footage of the building, as well as the types and quantities of electrical appliances and equipment that will be used. Overcurrent protection is required for all service entrance conductors to protect them from overheating and damage. The overcurrent protective device, such as a circuit breaker or fuse, must be sized to protect the conductors in accordance with the NEC. The overcurrent protective device must be readily accessible and located in a safe place. Grounding electrode system refers to the network of interconnected grounding electrodes that provide a path for fault current back to the source. The grounding electrode system typically includes a ground rod, metal water pipe, or other approved grounding electrode. The grounding electrode system must be properly sized and installed in accordance with the NEC. The grounding electrode system must be connected to the service equipment and the building's metal framework. Equipment grounding conductors must be installed with all branch circuits and feeders to provide a path for fault current back to the source. Equipment grounding conductors must be properly sized and connected to all metal enclosures and equipment. Bonding jumpers are used to connect metal parts of an electrical system to ensure that they are all at the same electrical potential. Bonding jumpers are required for metal water pipes, gas pipes, and other metal objects that could become energized. Bonding jumpers must be properly sized and connected in accordance with the NEC. When working with electrical systems, it's important to follow all safety precautions. Always disconnect the power supply before beginning any work. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools to prevent electric shock. Never work on electrical systems in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. The NEC is a complex and comprehensive document, and it's important to stay up to date on the latest requirements. The NEC is updated every 3 years, and it's essential to use the latest edition when designing and installing electrical systems. Continuing education courses are available to help electricians and other electrical professionals stay up to date on the NEC. These courses cover a wide range of topics, including service entrances, panel boards, conductor ampacity, and grounding. Proper electrical installation is essential for ensuring the safety and reliability of electrical systems. By following the NEC and using best practices, it's possible to create electrical systems that are safe, efficient, and durable. Always consult with a qualified electrician or electrical engineer for specific guidance on electrical installations. The information provided in this narration is for general informational purposes only and should not be considered as professional electrical advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. Electricity is dangerous, and it's important to take all necessary precautions to avoid electric shock and fire. By following the NEC and using common sense, it's possible to work with electricity safely. Remember to prioritize safety above all else when working with electrical systems. Conductors should be inspected for any signs of damage, such as cuts, abrasions, or corrosion. Damaged conductors should be replaced immediately. When pulling conductors through raceways, use a wire lubricant to reduce friction and prevent damage to the insulation. Avoid overbending conductors, as this can damage the insulation and reduce their ampacity. When terminating conductors, ensure that the terminals are clean and free of corrosion. Use a wire brush or emery cloth to clean the terminals if necessary. Apply an antioxidant compound to the terminals before connecting the conductors. Tighten the terminals to the manufacturer's recommended torque specifications. Use a torque wrench to ensure that the terminals are properly tightened. After completing the electrical work, inspect the installation to ensure that it is safe and compliant with the NEC. Check for any loose connections, damaged conductors, or other potential hazards. Test the operation of all circuits and equipment to ensure that they are functioning properly. Document the electrical installation, including the location of all circuits, equipment, and grounding electrodes. Keep the documentation in a safe place for future reference. Regularly inspect the electrical installation for any signs of deterioration or damage. Address any problems promptly to prevent them from escalating into more serious hazards. By following these best practices, it's possible to ensure that electrical systems are safe, reliable, and long-lasting. The NEC is a living document that is constantly evolving to address new technologies and safety concerns. It's important to stay informed about the latest changes to the NEC and to adapt electrical practices accordingly. Electrical safety is a shared responsibility. Everyone who works with electricity has a responsibility to follow safe practices and to prevent accidents. By working together, it's possible to create a safer electrical environment for everyone. It's important to remember that electrical work can be dangerous if it is not performed properly. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. A qualified electrician will have the knowledge, skills, and experience to perform the work safely and in accordance with the NEC. Don't take chances with electricity. Your safety and the safety of others depend on it. Prioritize safety above all else when working with electrical systems. Always disconnect the power supply before beginning any work. Wear appropriate personal protective equipment. Use insulated tools. Never work on electrical systems in wet or damp conditions. And if you are not comfortable working with electricity, hire a qualified electrician. By following these simple precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others.